Hello, everyone. We are here today to present a solution to a common problem: complex and often cumbersome connectivity in electronic systems. Our project is titled Simplifying Connectivity, the GPMI Cable Innovation. This represents an innovative design project conducted by our team, and it is our honor to have this work supervised by Professor Wallace. We are Group 1-2, and in the following presentation, we will walk you through the design rationale, the technical innovation behind the GPMI cable, and the potential impact it holds for making device interfacing simpler and more efficient. To help guide our session, we've put together a brief overview of what we'll cover today. This table of contents outlines the key sections of the presentation so you can follow along easily and know what's coming next. Before we dive into the technical details, we'd like to introduce our team behind this innovation. Leading our project is me, Tyree, serving as our team leader and coordinating overall efforts. Assisting in leadership is Ayman, our deputy leader. And driving the work forward is our dedicated core team: Bruno, Victory, Raphael, and Malik. Each of us has brought unique skills and perspectives to this project, and we are excited to now share the results of our collaborative work. Building on our team introduction, this slide details how we organized our work. To ensure the successful delivery of this innovation project, we established clear roles and divided the project into specific sections. Each member was assigned key parts of the report, based on their strengths, creating a structured and accountable workflow. This video showcases our innovative product and reflects our efforts to communicate its forward-thinking concept and cutting-edge design.
The way we connect our devices is about to change. Today, our homes, offices, and industries are filled with screens, computers, consoles, cameras, servers, and smart systems. But behind all this technology lies a growing problem. Too many cables, too many standards, too much complexity. Video needs one cable. Data needs another. Power needs a third. And Ethernet, adapters, converters, and extenders add even more clutter. This creates confusion, installation problems, higher costs, and massive electronic waste. That's where GPMI comes in. GPMI, the General Purpose Media Interface, is a new generation cable designed to do what no cable has done before: carry ultra-high-definition video, high-speed data, network signals, and high-power electricity, all through a single cable. Instead of managing 5 or 6 different connections, GPMI gives you just one cable, one port. Total simplicity. Behind this simplicity lies extremely powerful technology. GPMI supports up to 192 gigabits per second of data, enough for 8K and future 16K video, real-time AI processing, and ultra-fast file transfers. It also delivers up to 480 watts of power, meaning it can run and charge even the most demanding devices, from TVs and laptops to industrial machines and servers. This is not just faster than HDMI, DisplayPort, or USB. It replaces them. GPMI uses a hybrid design of copper and optical fiber, allowing it to carry massive amounts of information over long distances with almost no signal loss. Advanced shielding and intelligent power management keep everything stable, safe, and efficient. For users, the impact is immediate. Home entertainment becomes cleaner and simpler. One cable powers your TV, sends 8K video, connects your sound system, and links your network. In offices and studios, cable clutter disappears. Setup time drops. Reliability increases. In data centers, factories, and smart cities, GPMI reduces downtime, heat, and maintenance, while enabling high-performance systems to run through a single intelligent connection. And there is another important benefit. By replacing multiple cables with just one, GPMI helps reduce electronic waste, lower material usage, and improve energy efficiency. It is not just smarter, it is more sustainable. GPMI is already being adopted by some of the world's largest technology companies, including Hisense, TCL, Huawei, Skyworth, and many others, through the Shenzhen 8K UHD Industry Alliance. This means the ecosystem is real. The products are real. And the future is already starting. GPMI is not just a new cable. It is a new standard for how the digital world connects. Simpler, faster, cleaner, and ready for the technologies of tomorrow. Gpmi. One cable. Infinite possibilities.
This slide gets to the very heart of the need for innovation that inspired our project. In today's digital world, we are facing a growing problem: cable clutter and rampant compatibility issues. Look at any modern desk. It's often a tangled web of different cables and adapters. It isn't just messy, it reduces productivity and creates frustration. Furthermore, the demands of technology are skyrocketing. The rise of 8K video, AI applications, and the Internet of Things require more power and higher bandwidth than ever before. Next generation devices will push these requirements even further, yet the market response has been fragmentation. We have multiple competing standards: HDMI, DisplayPorts, USB, and separate power cables that are often incompatible with each other. This hinders interoperability and forces users to buy and carry numerous accessories. This leads to another crucial issue, which is environmental impact. The production and disposal of redundant cables and adapters contributes significantly to the global problem of electronic waste. So the question became, how do we solve this? Our answer is the GPMI cable innovation. GPMI is designed as a unified, future-proof solution. Its core mission is to consolidate power, data, and video transmission into a single, robust standard. It aims to eliminate the clutter, simplify connectivity, and reduce e-waste, meeting the high-performance demands of tomorrow's technology. GPMI Type-C is our vision for truly unified, high-bandwidth connectivity. The idea is simple but transformative. One port that handles video, power delivery, Ethernet, and high-speed data. No more juggling separate cables. At the physical level, GPMI builds on the familiar USB-C connector. Its reversible design hides an advanced array of high-speed data pairs, dedicated power lines, and layered shielding. Inside the GPMI cable, we used a hybrid architecture: an optical fiber core for extreme bandwidth, surrounded by copper lines for data and power, all wrapped in robust insulation. The real breakthrough comes from intelligent lane management. Specialized SerDes and PHY hardware dynamically multiplex different data types, packetizing them and sending them in parallel across available lanes. The receiving device then reconstructs everything with perfect timing. This approach revolutionizes video transport. Instead of legacy HDMI signaling, GPU output is packetized, streamed over GPMI link, and decoded at the display. This packet-based method unlocks far greater flexibility and scalability for future ultra-high resolution displays. Power delivery is fully integrated as well. Smart pH controllers negotiate voltage and current on the fly, ensuring safe, efficient charging, even while pushing high-resolution video and heavy data loads through the same cable. In short, GPMI cable Type-C isn't just a cable. It's a unified, intelligent connectivity platform designed for the next generation of digital devices. This slide highlights the core ambition behind GPMI, our vision and mission. We are not just building a cable, we are proposing a new, future-proof single-cable multimedia standard. Our vision is for GPMI to become the global benchmark for unified, high-performance connectivity. One cable that carries video, audio, data, networking, and power, reducing clutter, cutting electronic waste, and enabling next-generation displays well beyond 8K. Our mission is to develop, standardize, and promote GPMI as an open interface. Achieving this requires broad industry collaboration. We aim to deliver solutions that are efficient, interoperable, and cost-effective, supporting Ultra HD systems, AI-driven environments, and tomorrow's smart infrastructure. In short, the vision defines what we want: a simpler, more powerful connected world. The mission defines how we'll get there: through openness and collaboration. Now, Bruno will take over for the next 3 slides.
To position GPMI, we analyze the 2025 landscape. revealing a compelling opportunity at the intersection of three major markets. The global AV cable sector is substantial, projected between $1.5 and $3.5 billion. Simultaneously, the high-speed connector market is valued between $5 to $6 billion. Most critically, the premium 8K TV market, a key driver for high bandwidth demand, is estimated at $9 billion and are growing rapid rates at of 15 to 30% annually. However, the clear market gap is fragmentation. These are separate multi-billion-dollar product categories serving interconnected needs. No existing standard effectively consolidates ultra-high definition video, high-speed data, and power delivery into one solution. Consumers and manufacturers are forced to navigate this costly and inefficient complexity. Gpmi is designed to bridge this exact gap, creating a new unified product category that captures value from all three markets by solving their core interoperability problem with a single superior cable standard. Our path to market is a careful, phased rollout guided by a safety-first and quality-driven philosophy. Our implementation begins from 2025 to 2027 with the home entertainment sector, where we will conduct pilot deployments and refine our prototype for consumer AV systems. The second phase, from 2027 to 2029, targets the automotive industry, focusing on integrating with vehicle systems and rigorously validating safety and performance for in-vehicle video and data. The long-term vision from 2029 onward is expansion into industrial applications, scaling our solution for factory and commercial use with industrial-grade reliability. Throughout all phases, the installation will prioritize user safety with a plug-and-play, tool-minimal design. Each stage is supported by comprehensive testing and validation campaigns covering electrical safety, data integrity, video performance, and environmental durability. Finally, we will execute controlled deployment scale-up, moving from pilot production to full global rollout with strict quality gates in every step to ensure a reliable and successful product launch. Our path to market is a careful, phased rollout guided by a safety-first and quality-driven philosophy. Our implementation begins from 2025 to 2027 with the home entertainment sector, where we will conduct pilot. This slide details the two product tiers of Gpmi standard and how they outperform current solutions. On one side, we have Gpmi Type B, our proprietary high-performance variant designed for maximum capability. It delivers an unprecedented 192 Gbps worth of bandwidth and 480 watts of power, supporting 8K video at 120 Hz and beyond over distances exceeding 100 meters thanks to its hybrid optical core. On the other side, for broader consumer compatibility, we offer Gpmi Type C. It leverages the familiar USB-C form factor by dramatically enhancing it, offering 96 Gbps bandwidth, 240 watts power delivery, and supports 8K resolution at 60 Hz over 50 meters. Placed side by side with existing standards like HDMI, DisplayPort, and basic USB-C, the comparison is stark. Gpmi consolidates their separate functions while doubling or even quadrupling the individual performance metrics for bandwidth, power, and distance into a single unified cable for both tiers. Now, I'll be passing it to Raphael, who will talk about the next parts. This slide details the two product tiers of Gpmi standard and how they outperform current solutions. On one side, we have Gpmi Type B, our proprietary high-performance variant designed for maximum capability.
This slide details the technical architecture and confirms the feasibility of the Gpmi cable. Our readiness milestones show a clear development path. Functional prototypes were validated between 2023 and 2024. The custom ASIC chipsets required for signal processing are scheduled for mass production in 2025, and authorization for the Type-C variant from the USB Implementers Forum is being secured to ensure official compliance. The core of the design is a hybrid approach. It strategically uses copper wires to handle power delivery and short-range signals, while dedicated multi-mode optical fibers are employed to carry high bandwidth video and data over long distance, reliability exceeding 100 meters. This is built with key high-grade components, high-purity copper conductors, industry-standard multi-mode optical fibers, comprehensive multi-layer shielding that combines foils and braid to prevent electromagnetic interference, and custom-efficient ASIC chip from iSilicon to manage the complex signal multiplexing and conversion and the heart of the system. This architecture is proven, component source, and ready for scale manufacturing. This slide outlines the strong financial feasibility and return on investment for the Gpmi project. The business case begins with a clear competitive advantage in licensing. Unlike standard like HDMI, which charge per unique royalties and annual fees, Gpmi is structured for alliance members to benefit from low or no royalties, drastically reducing the bill or material cost. When combined with lower installation cost and the long-term operating saving for reduced e-waste and cable redundancy, the total cost of ownership is highly attractive. The initial investment for development and rollout is estimated between $110 million and $200 million, which will be shared and pooled across our strategic SUCA alliance partners. Our analysis project reaching the break-even point within 2 or 3 years after launch, corresponding to the sale of approximately 20 or 30 million units. Looking at the full 5-year horizon, the projected net return on the investment is substantial, ranging from 300 to 500% after accounting for all R&D certification and manufacturing setup costs. This demonstrates a financially viable and highly rewarding opportunity for partners. The Gpmi innovation delivers distinct advantage across 3 major user groups. First, for consumer electronics manufacturers making smart TVs, laptops, and gaming consoles, Gpmi enables significant design simplification by reducing the number of required ports, which directly translate to cost saving and the bill of material and during assembly. Second, for IT and data centers, operator managing server interconnects and AV over AP systems. Gpmi offers superior cable management and extremely high bandwidth in single link, which can also contribute to lower cooling requirements and simplified infrastructure. Finally, for large-scale industrial and smart city deployment, such as factory automation, robotics, and city-wide IoT networks, Gpmi provides the critical combination of high reliability, reduced downtime, and the ability to handle scalable long-distance deployments, all essential for robust, continuous operation in demanding environments. Now I would like to hand over the next section to Malik.
Our PESTEL analysis maps the strategic landscape for Gpmi. From a political standpoint, strong Chinese support for technological independence is a major opportunity for policy backing. Though geopolitical tensions present a threat to global adoption, economically, we are aligned with the booming 8K market growth in China, and our low royalty model offers a cost advantage. But we must compete with the deeply entrenched HDMI and DisplayPort ecosystems. Socially, a growing consumer demand for simplified, clutter-free setups is a powerful driver for adoption. Yet low awareness of Gpmi outside of China remains a key challenge. The technological foundation of our hybrid design and advanced chipsets is a core opportunity, but we must navigate the threat of rapid evolution from competing standards. Environmentally, the cable's role in reducing electronic waste is a significant sustainability benefit, though we must manage the threat of resource-intensive manufacturing. Finally, on the legal front, securing USB-IF certification provides validated standards, and flexible licensing is an opportunity, while potential export controls on embedded cryptography pose a compliance threat. Our SWOT analysis provides a clear strategic view of the Gpmi standard under the SUCA Alliance. Our core strengths are formidable, built on clear technical superiority with specs like 192 Gbps and 480 watts. The compelling value of a unified one-cable design, strong domestic backing from the SUCA Alliance and over 50 companies, and a cost-advantageous low or no royalty model for members. However, we must acknowledge key weaknesses, including a higher initial cost compared to established incumbents, currently limited global awareness and ecosystem maturity, and a dependency on adapters for full legacy device compatibility. Looking externally, Significant opportunities exist in the booming demand for AK, AI, and smart infrastructure, as well as for expansion into new verticals like automotive, industrial, and smart cities, all of which show a growing market preference for sustainable and efficient solutions. Yet we face serious threats from the global market dominance and brand recognition of HDMI and DisplayPort. Potential geopolitical barriers that could limit international adoption and the constant risk that rapid upgrades from competitors will narrow our technical advantage over time. This analysis defines both our competitive edge and the critical challenges we must navigate. We have conducted a comprehensive risk assessment across 5 key categories and developed targeted mitigation strategies for each. Technically, the primary risks are maintaining signal integrity and managing thermal output in a high-power, high-bandwidth cable. Our mitigation involves implementing advanced multi-layer shielding, integrating active cooling and thermal monitoring where necessary, and employing robust error correction protocols. From a market perspective, the dangers are slow adoption and aggressive responses from entrenched competitors. Our strategy counters this with aggressive partnership development within the Super Alliance and extensive education campaigns to build market demand and awareness. Operationally, we must guard against supply chain delays, which we will address by diversifying our supplier base and implementing lean manufacturing principles. For safety, the risks of overheating and electrical hazards are paramount. We are mitigating this through hardware with built-in protection circuits, pursuing all necessary international safety certifications, and providing clear end-user guidelines. Finally, regarding geopolitical risks like export control and trade restriction, our plan includes establishing dual certification paths for different markets and proactive diplomatic engagement with standard bodies and trade groups to ensure smooth market access. Now I would like to invite Victory to speak.
Hello guys, my name is Victory and I'll be taking through slide 18 to 20 ASAP. On slide 18, which covers market validation, and it says a 2025 freelance survey across IT professionals, engineers, consumers, and industrial experts confirmed that there's strong market demand, which covers about a low percent of 78% and a higher percent of 85% of respondents, which are dissatisfied with multiple cable setups and experience cable clutter, and 85% prefer a single unified cable solution over current fragmented systems, which validates our Gpmi as a solution to measure user pain point, not as a technical improvement. We're taking through slide 19, which covers the sustainability impact, whereas Gpmi enables a 30% to 50% reduction in cable-related e-waste by replacing the HDMI, USB cables, and power cables with one solution, where intelligent power management improves energy efficiency and reduces heat output, and also hybrid materials design optimizes copper use and increases recyclability. And also we support the UN SDGs. We have SDG 9, SDG 11, and SDG 12, where it covers industry innovation, sustainability in cities, responsible consumption, and also advances a circular economy approach. So on slide 20, which covers the future roadmap, where we covered on years 2025 to 2027, where the consumer adoption and cost optimization through scaled production, and from 2027 to 2030, it covers the major performance expansion, where we have 300 plus Gbps bandwidth, and we have 1 kilowatt of power delivery and enable 16K displays, both AR and VR. And beyond 2030, AI optimized routing and hybrid wired and wireless integration, where the continuous innovation in material science and recyclability, and also the positions where Gpmi as the core infrastructure of the future digital connectivity. From there, I would like to welcome Ayman, which will take over on the final sectors.
To lead markets, we're committed to visionary thinking and executing a clear strategic plan. Our immediate focus from 2025 to 2026 is to aggressively accelerate our momentum. This means rapidly expanding our ecosystem partnerships to over 100 members, launching targeted marketing campaigns in China to build early adoption, securing all necessary international certifications for global access, and developing a robust adapter ecosystem to ensure seamless compatibility with the vast installed base of legacy devices. In the medium term, from 2026 to 2028, we will leverage this foundation to expand into high-value verticals, specifically tailoring GPMI solutions to meet the stringent requirements of the automotive and industrial sectors. Through these focus actions, we will drive growth, inspire our teams and partners, and build the lasting competitive advantage needed to succeed in dynamic global markets. The Gpmi cable represents a truly transformative connectivity solution. It successfully integrates high-bandwidth video, data, and substantial power delivery into a single standard, addressing a problem for which we have validated clear and significant market demand. Our path to success is built on four key factors: a powerful consortium-based development model, undeniable technological superiority, a strong domestic market foundation, and intrinsic alignment with global sustainability goals. This powerful combination of collaboration, innovation, and responsibility is what will drive both scale and widespread adoption. Finally, we wish to extend our sincere acknowledgement. This project was made possible through the support of the SUCA Alliance, standards bodies like CESI and the USB-EF, our industry partners including Huawei, Hisense, TCL, Skyworth, and HiSilicon, our project advisor, Professor Wallace, and all the survey participants and industry experts who contributed to their valuable insights. In summary, GPMI is a unified high-performance cable standard designed to solve the critical problems of cable clutter, compatibility issues, and performance limitations in today's connected world. We have demonstrated that it is not only technically feasible with our hybrid design, but also financially viable with a strong return on investment and validated as market ready by clear user demand. The project has a clear pathway for strong domestic adoption within China, backed by strategic alliances with significant potential for subsequent global expansion. Ultimately, by consolidating connectivity, Gpmi actively supports broader goals of environmental sustainability, enables seamless digital transformation, and provide the robust infrastructure needed for the next generation of smart cities and industry. Thank you. Next, Tyree will explain about our learning outcomes about our first assignment, which was what is critical thinking.
Thank you, Ayman. We'll break down exactly what critical thinking is. At its core, it's a disciplined process that moves logically from identifying a problem through rigorous thinking and analysis to arrive at a well-reasoned solution. Let's begin by defining this powerful framework. Now let's dive into our key learnings of what critical thinking truly means. First and foremost, it moves us beyond simply gathering information. It is the systematic process of analyzing, evaluating, and reconstructing the information and arguments we encounter. To do this effectively, we employ a specific intellectual toolkit, which includes disciplined skills like interpretation, analysis, inference, explanation, evaluation, and self-regulation. A core and often challenging component of this process is the conscious effort to identify and question assumptions, both our own inherent biases and those presented by others. It's important to remember that critical thinking is never passive. It is active and purpose-driven, always aimed at forming a reasoned judgment or solving a specific problem. Ultimately, these points illustrate that critical thinking is more than a skill. It is a lifelong habit of mind. It is a personal commitment to staying open-minded, inquisitive, and rational whenever we face complex issues. And now, we will apply the principles of critical thinking we just discussed to a specific case study. This case study, presented by my colleague Bruno, explores what we call the strange rules of creativity and innovation. And now, we will apply the principles of critical thinking we just discussed to a specific case study. This case study, presented by my colleague Bruno, explores what we call the strange rules of creativity and innovation.
Is to examine how the structured analytical process of critical thinking can intersect with and enhance the seemingly unstructured world of creative innovation. This investigation by our team, Group 1, will reveal how these powerful modes of thoughts can work together to solve complex problems. So let's begin. Our investigation into the strange rule of creativity and innovation yielded several fascinating and practical learnings. First, we learned that constraint actually fuels creativity. Instead of being a barrier, the limitations and specific rules act as an essential scaffold. They focus our creative energy and prevent us from feeling overwhelmed by infinite possibility. This leads to the second key point: innovation is a process and not a mystery. It's not about waiting for a moment of genius, but about applying deliberate structured framework that can be managed and replicated. To make these frameworks work, we must challenge our deepest assumptions. True innovation requires us to actively question industry norms and the entrenched belief that this is the way it's always been done. Furthermore, we must completely reframe our relationship with failure. In the mindset, a setback is not an endpoint, but a vital piece of data. An expected result becomes critical feedback that can pivot us towards new pathways and insights. Finally, we found that cross-pollination is absolutely key. The most powerful breakthroughs occur at intersections of diverse fields, perspectives, and seemingly unrelated concepts. It is these forced connections that reliably spark through novelty and lead to innovative solutions. In this slide, we will be viewing some of the screenshots of our case study that we conducted. Now, to bring our key learnings on creativity and innovation into a concrete example, we will explore a case study that demonstrates the practical application of these rules. This segment, presented by Ayman, is aptly titled "Creativity is Always Achieved Step by Step."
It will show how critical thinking provides the discipline's analytical framework that allows creative ideas to be built and realized systematically, one deliberate step at a time. Through this real-world example from our team, Group 1-2, we will see theory put into practice. Our case study reinforced the central idea that the creativity is a methodical journey. The first and most important learning was that we successfully debunked the Eureka myth. True creativity is not a sudden flash of genius, but a disciplined process with distinct stages: preparation, incubation, illumination, and verification. This leads directly to the second point. We learned to embrace the power of iteration. Each step, whether it's initial research, rough drafts, prototypes, or gathering feedback, is essential. What we might call a bad first attempt is not failure, but a necessary foundation that allows for refinement and improvement. Furthermore, we saw the immense value of structured collaboration within a team. Having a clear step-by-step framework allows a group to channel diverse and sometimes chaotic ideas into a constructive process. This structure turns individual creative sparks into a single, shared, and polished outcome. Finally, this model redefines our understanding of creative blocks by recognizing creativity as a step-by-step process. We learn that the block is not a full stop. Instead, it is a signal, a sign that we need to persevere, revisit a previous step, or simply approach the problem from a new angle. Persistence, guided by this process, becomes the true key to creative achievement. A screenshot of our case study.
These slides show our innovative product report. Here's what we took away as a group from the critical thinking course. Each of us brings our own viewpoint, but when we look back, it's the shared moments that stand out. Long discussions, tackling case studies side by side, bouncing around ideas during creativity exercises, and digging into the Gpmi cable project together. Sure, we each had our own personal takeaways. You'll find those after we talk about our group learning outcomes. But here, we're focusing on what we built together, the way we learned from each other, faced challenges as a team, and came out stronger as Group 1-2. From my perspective, our group's journey through this project was a powerful, real-world application of the principles we studied. The first and most valuable learning was the strength that comes from our diverse perspectives. By bringing together different cultural and academic backgrounds, we were able to constantly test our assumptions and generate stronger, more robust ideas. We also experienced the importance of balancing what seemed like opposing approaches. We learned to mix analytical and creative thinking to tackle complex problems, much like the three-box solution model we studied. This required us to continually adapt and evolve, identifying our own unproductive habits while managing our current tasks and searching for new insights. The process taught us how to move from raw creativity to solid structure. Our brainstorming sessions often started in a state of creative chaos, but by refining and building on those initial ideas step by step, we were able to develop truly innovative and yet structured solutions. Underpinning all of this was a spirit of humility and collaboration. We learned that by working together, we could break down complex tasks into manageable pieces and combine our collective evidence and knowledge to build practical solutions. The overarching lesson we take away is that innovation is a collective journey. As our experience proves, we cannot innovate effectively in isolation.
From my perspective, our collaborative work showed how innovation truly emerges in a team through debate, critical thinking, and frameworks like Innovators DNA and the three-box framework. We strengthened ideas by leveraging individual strengths while balancing present demands and future exploration. By using futurist tools such as Cypher and scenario building, we identified emerging trends and developed creative solutions for the aviation sector. Most importantly, we learned to take calculated risks, see failures as learning opportunities, and refine bold ideas into practical solutions. This experience confirmed that creativity thrives in a dynamic, exploratory group process.
My reflections on our group work center on the social and resilient nature of real innovation. Practice what I call social critical thinking. By blending our diverse perspectives, actively exposed our individual blind spots, and deepened our collective ideas, much like the T-shaped teamwork. A key part of our process was balancing raw ideas with rigorous analysis. We began by brainstorming freely to imagine the future of connectivity, and then used structured tools IFA method to refine those visions into actionable, practical steps. To keep this process effective, we maintain resilient team dynamics. We made a point to regularly check in our group's interactions, and applying three-box framework helped us move past conflicts and channel our energy into building real prototypes. This progress was built on humility and iterative cycles. Through repeated rounds of open discussions and hands-on prototyping, we made even the most complex aviation design challenges manageable. Perhaps most importantly, we learned to treat setbacks or failures as essential lessons. When something didn't work, we analyzed it together, adapted our approach, and collectively moved forward to discover new solutions. The fundamental lesson for me is that critical thinking thrives as a social effort. True innovation for our team wasn't a solo activity. We had to connect, collaborate, and think together to create something meaningful.
My perspective on our group's process highlights the role of critical thinking in guiding team innovation. A key part of our work involved learning how to hedge and negotiate disagreements. By continuously testing our Gpmi concept over multiple iterations, we learned to use constructive strategies to manage differing viewpoints, turning conflict into a tool for improvement. We applied our learning to spot patterns in long-term trends. Using scenario building techniques, we were able to forecast future connectivity trends, which gave us a clearer framework to understand and compare technical standards like Gpmi and HDMI. To organize our efforts, we balanced our team's expertise by intentionally splitting into discovery and delivery roles, a structure inspired by our case studies that allowed us to leverage our different skills effectively. Our most creative work came from shaping seemingly crazy ideas into realities. This happened through a collective process of questioning norms and rigorously mixing creative speculation with solid evidence, which allowed us to transform out-of-the-box concepts into practical solutions. None of this would have been possible without a foundation of open and honest conversation. These direct discussions were essential for breaking down complex projects like Gpmi into simple, actionable steps that everyone on the team could grasp and execute. The central lesson I take from this is that open, honest dialogue is not just helpful. It is the fundamental key to building a team that is adaptable, evidence-driven, and capable of genuine innovation.
My reflection focused on how our group applies strategic thinking to adapt and succeed. We began by learning to hedge uncertainties, directly applying the hedging concept from our first case study to navigate the unknowns of our Gpmi project. Throughout continuous testing and building resilience into our plans. A major part of our alignment comes from forecasting together. By collectively analyzing trends and building scenarios, as we studied, we were able to spot potential outliers and extreme. This shared process helped us get on the same page regarding technical choice like Gpmi versus HGME. We also made a deliberate effort to play to our individual strengths. Taking inspiration from the case studies, we balance the discovery of new Gpmi concept with the practical delivery of results by intentionally mixing our diverse team skills. A significant achievement was our ability to shape even our most creative ideas into something viable. By committing to a disciplined, step-by-step creative process, we were able to give our wildest concept legitimacy and tangible value within practical limits. Underpinning all of this progress were honest, direct conversation. By constantly questioning our own assumptions, especially around complex topics like multi-signal unification, we were repeatedly guided towards simpler and more efficient solutions. The lesson I take away is clear. The combination of candid dialogue and the intentional blending of our different skills is what builds a team that is truly adaptive, cohesive, and effective.
Which I give my personal reflection and the key lessons I've learned from our project, in which our journey blended critical thinking with real innovation, with starting with critical honesty, admitting that we didn't know, so we could execute today while we're still building the future. We learned that a scenario balance, which combines a bold long-term projections such as Cypher with the real world constraints and keep solutions ambitious but realistic. And also we improved by separating and integrating discovery plus delivery free brainstorming paired with discipline execution by innovators' DNA to sharpen and ground ideas. Also, we treated setbacks as a fuel, iteration from failure, using persistence and old rules to refine prototypes. And also the biggest takeaway is the success for the team achievement, driven by evidence-based decisions and unity, enabling complex and higher bandwidth integration. The closing message is evidence plus teamwork withstands the bold ideas into durable working results.
Our final collective insight represent the major lessons we learned by working together to turn theories into tangible actions. The foundation of everything was balanced analysis. I would consistently use the principles of critical thinking to cut through complexity and identify the true cause of each problem we face. We then applied our skills in future trends planning using forecasting and scenario building techniques to look beyond the present and anticipate potential changes on the horizon. The right solutions will foster an innovative mindset within the team, actively encouraging creative thinking and welcoming diverse ideas to spark genuine innovation. To manage risk, we adopted a hands-on approach of prototyping for safety. By building and testing physical or conceptual models early, we were able to validate ideas and identify pitfalls into a controlled way. Integral to this entire process was our shared attitude of embracing failure. We learned to treat mistakes not as endpoints, but as valid data points that would build our team's resilience and directly led to improved solutions. Together, these practices allowed us to move from abstract insights to concrete impact, proving complex problems are best solved through a unified discipline and collaborative effort.
Now we'll talk about our individual learning outcomes. On an individual level, my key learning outcome was integrating several powerful frameworks into a cohesive approach. I learned to apply the three-box solution for strategic management to effectively manage the present, consciously let go of outdated practices from the past, and systematically build for the future. I also developed practical skills in futuristic techniques, such as identifying trends with the cipher model and using scenario building to anticipate change. This was combined with strengthening my core critical thinking skills, specifically learning to rigorously analyze information, question my own biases, and seek solid evidence before making decisions. This analytical foundation supported a more disciplined creative process. I moved from initial brainstorming to a cycle of testing and refining ideas, which gave me the confidence to take calculated, smart risks. All these skills were directly applied to our Gpmi cable project, where I engaged in hands-on research and prototyping to develop real-world tech solutions. Ultimately, my learning journey followed a clear path, starting with deep problem analysis, applying structured futurist and critical thinking tools, navigating a creative process, and finally arriving at tangible technological innovations.
For me, the biggest takeaway was how critical thinking transformed my approach to problem solving. I became better at identifying logical flows, synthesizing different perspectives, and collaborating more effectively as a team. Through our case studies, I applied these skills by breaking old debates, tracking emerging trends using the Cypher model, and structuring teamwork with the T-shaped skills. Overall, this process taught me not to only to anticipate future change, but to actively help shape it.
As a member of this group, this course was revelation in how practical critical thinking can be. I learned it is real step by step by consciously digging deeper into problems, actively questioning my own assumptions, and genuinely listening to different viewpoints. I consistently arrive at stronger answers in both debates and assignments. This structured thinking was applied directly to our case studies. In the first study on letting go, I embraced the concept of selective abandonment for box 2 of 3 box solutions. I learned that deliberately letting go of past methods is not a loss, but a necessary step that clears the path for constant innovation. The second study on evolving strategies introduced me to the Cypher tool. Using its components, tracking changes, indicators, patterns, and horizons taught me how to ask better, faster questions that improve rapid response and strategic foresight. Finally, the third step on innovative solutions showed me the power of combining leadership with diverse team insights to drive valuable, tangible processes. Throughout our project, from brainstorming device challenges to building prototypes, I relied on structured frameworks to guide our work, understanding discipline, value captured in what turns creative ideas into real-world solutions.
For me, this course and its focus on critical thinking fundamentally opened my mind to new ways of approaching ideas. I built concrete skills in carefully weighing evidence, constructing strong arguments, and systematically tackling complex topics. I applied these skills across our 3 case studies. The first study taught me about adapting for progress. I learned the importance of hedging for flexibility and, most crucially, the discipline of box 3 iterations, the step-by-step process of building and refining the future through continuous cycles of improvement. The second study focused on balancing intuition with analysis. Here I mastered the Cypher method, using its components, tracking changes, indicators, patterns, horizons, and emotional timelines to forecast potential breakthrough changes with a more balanced and informed perspective.
For me, this course re-speed my approach to learning. Critical thinking opened me to new ideas and gave me practical skills in carefully weighing evidence, building stronger arguments, and truthfully consider my options before taking action. This new mindset was applied directly to our case studies. The first study taught me that progress required change. I learned the crucial principle that box 2, letting go of past habits, it was truly frees up resources and mental space for box 3, allowing us to pursue long-term possibilities. It also emphasized the importance of resource balance, strategically allocating time, funds, and talent to power real innovation through a cycle of discovery, connection, prototyping, and solving. The second study introduced me to speculative thinking. It pushed me to look beyond my own industries, challenge foundational assumptions, and test bold what-if strategies by analyzing change indicators and patterns to find creative solutions. The third study focused on driving innovative teams. I was inspired by models like the eBay style leadership duo, which show some show how leaders with diverse and complementary expertise can inspire groundbreaking results. This approach guides a team from a shared vision to a tangible prototypes, improvising early ideas into workable solutions. All these concepts were tested against real-world benchmarks, like comparing existing Gpmi standards at 48 Gbps against our project target of achieving a 192 Gbps bandwidth, pushing us to define and pursue what a true breakthrough looks like.
The final idea for me where the biggest change is that critical thinking stopped being just a classroom idea and became a personal toolkit for turning confusion into clarity and making sure that my ideas are backed by strong reasoning. Also, across the case studies I did, and I learned three core lessons. First, I developed a more adaptable mindset, which balances intuition with humility. Also, choosing safer evidence-based decisions over few forced answers, and also using both logic and creativity to fully understand problems. Secondly, Cypher trained me to look beyond normal growth patterns by noticing weak signals and dramatic moments that can indicate major future shifts while still keeping the right balance between imaginative discovery and discipline. Thirdly, I gained a practical method for refining ideas into outcomes using a structured team creativity steps by treating failure as a necessary part of iteration and intentionally combining different team strengths. We applied all this through the Gpmi process, discovering, connecting prototypes, solves to stay aligned benchmarks against standards like HDMI and maintaining continuous learning. Thank you very much for today.
As we bring our presentation to a close, we, Group 1-2, Tyree, myself, Ayman, Bruno, Malik, Raphael, and Victory would like to offer our sincere thanks. Professor Wallace, thank you. This was more than just a course on critical thinking. It was a transformative journey. You equipped us not just with the frameworks like the three-box solution or cipher, but with a new lens to see the world, to question assumptions, embrace disciplined creativity, and build futures with intentions. From our first chaotic brainstorm to our final prototype, you guided us to channel our diverse perspectives into a single, powerful engine for innovation. You taught us that the strongest ideas are forged in the respectful clash of debate and polished through collaboration. So from all of us, thank you for the challenge, the insight, and for showing us that true power of critical thinking lies in the ability to connect ideas with evidence, creativity with structure, and individuals with a shared purpose. This is a lesson we will carry far beyond this classroom. Thank you.